for this problem, you want to find the limits of the functions at several x as x approaches several values. So think of limits as the y value that a function approaches when your x approaches that certain value. So in part A, we have the limit as x approaches 7. So as the function approaches 7 from both sides, you will notice that it seems to, well, it seems to go off the page continuously. And it actually looks like the x equals -7 is an asymptote. So the limit should be negative infinity. Or sometimes, depending on your teacher, they might say this does not exist. But I would say more specifically that this y value that your function approaches is going to be negative infinity. Okay, so part B, as x approaches -3 from both sides. In this case, it looks like the function is just tending toward infinity, so positive infinity. Oops. Oh, okay. So positive infinity there. And for part C, as x approaches 0, your function also looks like it's tending toward infinity. So part C should be infinity as well, unless your teacher defines that as does not exist. But I would say infinity is usually the accepted answer there. Okay. Right, and part D, as x approaches 6 from the minus side. So from the left side, let's take a look. 6 from the minus side. Okay, so the function, when the function approaches 6 from this side, it looks like it's tending toward negative infinity. So part D, that should be negative infinity. And for part E, as x approaches 6 from the positive side, that looks like it is. It looks like it is approaching. The function is approaching positive infinity this time. And as a side note, because the limits from both sides do not match, this in fact, the limit as x approaches 6, so neither from the positive or negative, but just in general, this would actually be equal to does not exist. So this limit will actually not exist. Wow, this writing tool is not great. Okay, but that should be D and E. Okay, and now we want to write we want to find the equations of the vertical asymptotes. So the vertical asymptote is just places, so lines where the function will come very close to but never quite touch. So the smallest vertical asymptote, let's take a look. So the smallest one looks to be the asymptote that will be at x equals -7. So x equals -7, your function looks like it's never quite going to touch x equals -7. As from part A, the limit was negative infinity. So x equals -7 is our smallest asymptote. Okay, and the next one, so we will just look at all the places where the function seems to tend toward infinity or negative infinity. So the next the next one up is going to be x equals -3, and then it's going to be 0, and then the next one is going to be 6, which is the largest equation, largest asymptote there. So -3, 0, and 6 are the last three. And that is what we have.